Hello, in this video let's study the variation of the resistance of a conductor with temperature. When you heat or increase the temperature of a conductor, its constituent atoms get excited and start to vibrate with higher amplitudes. This means that the free electrons collide more and more with the atoms in the conductor and get hindered. Thus the conductor becomes more resistant to the flow of current through it. So the resistance of a conductor increases with increasing the temperature. Now let's do a small experiment to obtain the relationship between the temperature and the resistance of the conductor. In this experiment, a conductor is connected to an ohm meter to measure its electric resistance. The temperature of the conductor is then slowly increased by placing it in a test tube of glycerol, which is in turn placed in a beaker of water which is heated by a Bunsen burner. Here we use glycerol in the test tube as it is a better heat conductor than water. The water is heated very slowly to try to maintain thermal equilibrium between the water and glycerol and conductor. Also, the water can be stirred well to obtain the thermal equilibrium between them. And before taking the resistance reading, take out the burner and wait until temperature becomes steady. Similarly, take a number of resistance readings at higher temperatures. Now, from these experimental data points, we can plot a graph of R versus theta. Then we will obtain a straight line of positive gradient and positive intercept. The intercept is equal to R0, which is the resistance of the conductor at 0 degrees Celsius. And the gradient is equal to R minus R0 divided by theta minus 0. Here, R is the resistance of the conductor at theta Celsius. Okay, now we will see what is the temperature coefficient of resistor. The temperature coefficient of the resistance is defined as the change in resistance per unit resistance per degree rise in temperature based upon the resistance at 0 Celsius. So from the definition we have following formula: alpha equals to R minus R0 divided by R0 theta. The SI unit of alpha is per Celsius or per Kelvin. In the previous slide, we obtained the gradient and the intercept as follows. The gradient is equals to R minus R0 divided by theta minus 0 and the intercept is equals to R0. By inspecting these equations, we can see clearly that we can obtain the temperature coefficient of resistance from dividing the gradient by intercept. By rearranging the first equation, we can get R equals R0 plus R0 alpha theta. Therefore, R equals to R0 times 1 plus alpha theta. Finally, let's do an example. The resistance of a wire is 11 ohm at 20 degrees Celsius. What is the resistance of this wire at 40 degrees Celsius? In brackets, the value of alpha is given, which is the temperature coefficient of the resistance of the given wire, and it is equal to 0.00393 per Celsius. Before I answer to this question, you may pause this video and try once by yourself. Okay, I hope you all have found the answer to the question. So let's see how to solve this problem. Now we know that the relationship between resistance and temperature is R equals to R0 times 1 plus alpha theta, and it has given that the resistance of the wire is 11 ohm at 20 degrees Celsius. So I can write 11 ohm is equals to R0 times 1 plus 0.00393 per Celsius times 20 degrees Celsius. Let me take this as my equation number 1. And we want to find the resistance at 40 degrees Celsius. So I can write R equals R naught times 1 plus 0.00393 per Celsius times 40 degrees Celsius. I will take this as equation 2. So we can clearly see that we can get rid of R naught if we divide equation number 1 by 2 or 2 by 1. Actually, it's a crucial thing to do since we don't know the resistance of the given wire at 0 degrees Celsius. So now I'm going to divide equation number 2 by equation number 1. And after some steps of numerical simplifications, we can get the final answer as 11.8 ohms. That's it. We are done with this part. And if you want to learn about equivalent EMF of a system of series of batteries, check out this video of my suggestion. Take care.